Mattel Toy Company released a Barbie doll in 1977, and the Barbie said, in Barbie's voice, which I won't attempt to do, but the Barbie said, "Math is hard." And at that point, there was an uproar, and Barbie was pulled off the shelf because people were afraid that young girls and growing into women were not going to feel like they could do math. So that Barbie was pulled off, but I still feel like we have that same problem. This morning, I want to tell you a little bit about Gateway's East-based STEM network. We knew we wanted to work cradle to career. What we discovered is that there were 4 excellent areas for us to focus our energies. Math education in early years, STEM learning in out-of-school time, the transition from high school to college and then on to career. And then the final area is professional development for educators. We try to inspire more people to act. And that's what brings us here today.
Thomas Jefferson believed that our democracy depended on having an informed, literate citizens. Abraham Lincoln established the land-grant college systems in several of our UC campuses. Franklin Roosevelt had the vision to sign the GI Bill into law, enabling 2 million servicemen and women to attend college. Dwight Eisenhower signed a bill authorizing the first student loan program. The impact of the visions and actions of these strong leaders fueled a nation that has prospered for centuries. And while today our world has changed, the importance of a strong system of public education has not. Education is and always has been, and I want to say this again, the real engine of our economy. Preschool has to be part of the solution. We know that early knowledge of math not only predicts later success in math, but also predicts later success in reading. And that's why our ability to educate our children and to integrate STEM into our schools is critical to our economic success.
So why should we care about early mathematics? We care because research says that it's very important. Greg Duncan, who primarily studies child poverty, decided that he and his colleagues wanted to look at the predictors of later academic achievement. When they looked at the predictors of reading achievement at 3rd and 5th grade, you'll see that math is just as predictive as early reading. If children at ages 6, 8, and 10 fall in the bottom quartile of all of those points in time, the likelihood of them completing high school drops by 13%. So the idea here is not to say don't support early literacy. The idea is that you should be paying as much attention, if not more, to early math development.
What our program aims to do is to provide a bridge between the preschool and the elementary school. We want to regularly bring together teachers to work within their grade levels, but then to also work across grade levels. Because if they're not speaking to each other, then they don't know what the children have learned and help that child continue to grow in their math understanding. We also provide professional development in the Preschool Learning Foundation. We look at increasing student math talk in the classroom and also supporting teachers to examine student mathematical thinking. So what are our teachers saying about this program? 75% of our preschool through 3rd grade teachers reported that they increased math planning instruction by quite a lot. So we see here that our teachers are reporting that they are changing their instruction and the time they're spent thinking about math and supporting students in math.
So this is kind of our theory of action. The first step is understanding the mathematics. How can we get engaged students around the big ideas, and then we focus on teacher support, and then from there we also work with some administrators. It's a real iterative process. It's not linear. How can we revisit each step each time?
Like, what does early math look like? What we're going to do today, what you're going to do is you're going to count.
Areas that people are the lowest on, even the high school kids, is they don't know how to set up a chart by themselves or a graph or how to read it. So if we tell them how to do it and keep providing all the charts and the systems, then they're never going to learn how to create a system for themselves.
So anything that you do with children, as much as you can to count stuff, In one school, I guess, they try to figure out how many books are in the library. Anything like that. And so the thing that you're doing as preschool teachers is laying the foundation that they can't get any other way.
It's been known for many years, certainly since the 1960s, that there's a math gap tied to SES. The SES gap is already there at age 3. So that's why I said they bring it with them from home. What we find is that kids from low-income families in the U.S., they're getting less support both at home and in the preschool classroom. Children in public preschool programs are not receiving effective math curriculum. What's going on in China? Notice that instead of widening, that gap narrows over the preschool year. They have universal preschool. There's a slot there for your child. China has a national curriculum for preschool, and math is part of that curriculum. Chinese parents have higher expectations than American parents. Chinese teachers have higher expectations than American teachers. You can see here that math is the highest predictor of later learning. It's very important to provide a strong foundation in early mathematical knowledge. It should be a major educational priority.
We are tough. We go in, when we do the intervention with teachers, we really ask them to implement with fidelity. As a result, we hold the bar higher, people will reach that bar, and the children will do very well. You don't get the kinds of gains that we get in our interventions by just exposing children to an activity. Pre-kindergarten children who are in the treatment condition exhibited impressive gains in their mathematical knowledge and was almost double that of control children. So the takeaway message here for policymakers is that we really encourage public preschool programs to implement effective math curricula.
All of the activities are hands-on, they're developmentally appropriate, they're very engaging. The kids who get these home activities at home, they do so much better in the classroom. Well, mathematical practices. These are things we want children to be able to do, to use problem solving and persevere in their problem solving, to reason abstractly, quantitatively, construct viable arguments, model with mathematics. There are a lot of cursory skills and foundational skills that children will need in pre-K in order to be ready for those Common Core standards once they get to kindergarten.
Preschool age kids develop an informal understanding of measurement through experience with playing with objects. Teachers can, of course, encourage development of the precursory knowledge by having children look at objects, directly compare them, order them, different sizes. Really important aspects of it is also for kids to develop mathematical language.
The unique thing about ELM is that it has a specific emphasis on vocabulary. Math has a lot of vocabulary, and children don't necessarily come knowing that vocabulary. We want these kids talking about math. Most important math practice, I believe, the Common Core is getting the children to defend their own thinking. It's really important, and it's not happening enough.
So the first thing that we'd like for you to talk about in your facilitated small group, the implications of what you heard this morning for you personally. And then the second thing that we'd like for you to work on for us, we'd like you to help us develop some short, simple messages that we could share with somebody, or that we could use to start a really traditional kind of messaging or PR campaign to encourage other people out there in the early learning community, or not in the early learning community, in the policy community, in the education community, in the business community, about how important this work is.
all those groups. So a lot of the same kinds of things I think other people were talking about. And we ended up with this message that we have, which is Early math starts at home before we teach it, and we use it long after we learn it.
We're all born the same with the same basic cognitive ability to do math. But somehow along the way, unique to this country, we say frequently, I'm not good at math. And I think that would be a really good place to start if we would change that message.